We often want to use information about a derivative to approximate information about the original function. In fact, although this material only gets a single section, it's fair to say that that's one of the main applications of calculus. Let's try to motivate this by looking at an example. And this is really a calculus 3 problem, but hope because there are multiple dimensions here, multiple variables, but I hope it will be clear enough. We have a river. The water is flowing in this direction. And we've got a dock, and this river has all the complications you might expect a river to have. Let's say there are rocks sticking up, there are branches and logs that have fallen into the river. Sometimes it deepens, sometimes it's shallow, sometimes it's wider than it is in other places. So a river, in other words. And let's say you stand at the end of the dock here and you release a toy boat. And you want to define a function that takes as its input the amount of time since the boat was released and gives as its output the location of the toy boat. And all I have to say about this is good luck. If this is a lengthy stretch of the river, and you want time to be a relatively large number, this basically can't be done. This is what is meant when people talk about chaos theory, that very minor changes in how the boat is released can cause dramatic changes to what happens to it. Maybe if you release the boat just 1 foot upstream, it goes around this rock. Or maybe it goes in this direction and gets caught up in the log. This is just too complicated to try to create a mathematical formula that's going to do what you want it to do. But suppose on the boat is a little super sensitive GPS or some other kind of position finder. Let's say after some time has passed, the boat is there, And if you're keeping track of its position at time t, you're also keeping track of its speed and direction. So maybe you know the boat is traveling in this direction, and you know what speed the boat is traveling at. Then surely in the short term, you have some idea of where the boat is going to be. Like you can say that in a second, the boat should be somewhere around here. In other words, you want to take, if you'll pardon a small pun, the current position of the boat and its velocity to predict the future position. The material of this section is designed to let us solve problems like this one.